Okay, hello. So it's Mr. Liu again. This is for the Physics 1 class. And hopefully you just watched the video that was about rates that it gave you from Khan Academy, just to make sure exactly what a rate is. And if you recall from that video, a good way that he put it is a rate, it's a relationship from how much of one thing for every how much of something else. Okay, now, in this lesson, we're going to talk about two very important rates called, and I'm going to put it here, speed and velocity. Speed and velocity, all right? Now, in both of these rates, basically they are both about how fast something's going. How fast are they going? But in these two situations of speed and velocity, there's going to be some differences that make them, I guess, considerable enough to know the difference between the two of them, okay? They're often used interchangeably. Like when people talk in everyday language, they say, okay, well, the speed of the car was this, the velocity is increasing, and they're not necessarily being super accurate if they mean speed or if they mean velocity. I think most of the time when people say velocity, they're probably meaning speed, okay? I'll get into all that though. So let's look at first what an example of a problem that could use speed or velocity. So it says right here, Christian starts at his house and he travels in his car and he goes 60 kilometers north to his mother's house. This takes 2 hours. He heads in a straight line the entire time. What is his speed and what is his velocity? Okay, so in order to do this, we have to kind of understand how to calculate speed and velocity. There's going to be like formulas in order to calculate both of these rates. Okay, so why don't we get right into it? What would be the difference between the two of these? All right, so I'm going to put a little line here that separates them. So for speed, speed is going to be a scalar quantity. And then that makes velocity, what's the opposite of scalar, is a vector quantity. All right. Now, if you remember, scalar has no thought about direction. So if you walk forward 1 meter, you walk backwards 2 meters, scalar would just say, all right, you went 1 and then you went 2. Well, that means you walk 3. There's no sense of, going back the other way is negative and going forward is positive. Vector, on the other hand, has a sense of direction, all right? So there are arrows involved with this. So when you walk forward 2 and then you walk backward 1, from a vector perspective, well, you only went 1 forward because turning back just kind of canceled out one of the steps you took in the forward direction, okay? So this difference kind of illustrates the difference between speed and velocity. Okay, so since speed is a scalar quantity, when you think about how fast you're going, you have to incorporate something we learned about in a previous lesson, which is the concept of distance and displacement. Okay, that was how far did you go, was distance and displacement. And just like then, one of those quantities was scalar and one of those quantities was vector. If you recall, the scalar quantity was a quantity called distance. So when you calculate how fast something's going and you're talking about speed, you're going to be thinking about the distance that the object travels in addition to the time, okay? Now, on the other hand, for velocity, you're also talking about how fast you went or something went, but you're not thinking about how far did it go in distance. You're thinking about it in terms of directions, like a vector. So it's not distance. What was the equivalent of distance that was vector? If you remember, that was displacement. Okay? So when we use formulas to calculate both of these, we're going to have to remember that one is completely thinking about it with direction and one isn't. Both of them involve the unit called time, though, all right? So for speed, it's going to be figured out like this. The speed of something, the rate of speed, or I guess speed is a rate. Speed is going to be figured out by taking the distance that something traveled and dividing it by the time it took to travel that distance. Whereas velocity will be similar. It'll be the displacement something experienced divided by the time it took to get displaced. Now, as far as the number goes, so like speed, for example, might be like 30 miles per hour. Velocity might be example like 30 miles per hour, but we would need a direction because this displacement had a direction, if you recall from the previous lessons. So it could be, for example, 30 miles per hour north. Now notice these two don't seem all that different. And here's like a little way to think about it is both of these, they are the same. They are the same for the number. Okay, maybe we say they the same number until there is a direction. Oh, getting out of my box here. Until there's a direction change. So speed and velocity, as far as the number, like 30 miles an hour, 30 miles per hour, those numbers are going to be the same. You know, one's going to have a direction and the other's not, but they're going to be the same number up until the point when the person, car, whatever it is that you're looking at that moment for the problem, turns around. Once it turns around, comes back the other way, or takes a left or takes a right, once there's a directional change, then they're not going to be the same number. But up until that, they're going to be the same. Okay, so the formulas you have to remember are here and here. All right, and let's use it for a problem now. Just a straight, what is the speed, what is velocity? We'll just calculate it. Okay, in this problem, this is the one we talked about. Christian takes his car, he goes 60 kilometers north to his mom's house, takes 2 hours, goes in a straight line the whole time. What is the speed and what is the velocity? Okay, so first thing let's do is let's dissect the words in the problem and figure out what information we know, what information we want to know. Christian starts at his house, okay, travels in his car, goes 60 kilometers north. Goes 60 kilometers north to his mother's house. This takes 2 hours. Another important piece of information there. He heads in a straight line the entire time. What is his speed? What is his velocity? Make sure I am recording, right? Okay, all right, good. Okay, so in this situation, let's figure out what we know. Okay, so what we know is we know that Christian traveled 60 kilometers north in a straight line. So I guess there's two ways you could look at it. You could say, well, that means he went a distance of 60 kilometers. Okay. Or if you said, well, okay, actually that also could be thought of as a displacement because it said very clearly what the direction is. And it's a straight line. The person never turned around. Christian never turned around. So the displacement, 60 kilometers north. Okay, there's one more important piece of information here. This takes 2 hours. What is that? That would be the time. 2 hours. Okay, what is the problem asking for? Well, let's just go to the end where we see the question mark here. What is his speed and what is his velocity? So we are looking for speed and we are looking for velocity. What are the formulas we're going to use? Okay, so we go back here now and say, what is the formula? This formula is equal, for speed is equal to distance divided by time. Let's go ahead and abbreviate that though. Let's shorten those things. So I don't have to write the whole word speed equals the whole word distance and time. Okay, so what color did I use for that? I used red for speed. Okay, to abbreviate speed, I'm going to use S. Some of the times people use R to show like it's a rate, but I'm just going to use S for speed. Equals for distance, I'm just going to use the letter D. And divided by, for time, I'm going to use a lowercase little t here. Dividing line, okay, let's go back and look at the velocity formula. Velocity is equal to displacement divided by time. Okay, so for velocity, I'm going to use a small lowercase v. For displacement, I'm going to put a d, but I'm also going to put like a little arrow above the d to signify that there's like a direction there. That makes it displacement instead of distance. Divided by also a little t for time. Easy enough. Now all we do is we substitute in the numbers. Well, we have said that the time is very clearly 2 hours. That'll be substituted here, and that'll be substituted here. And then we also saw that distance, in this situation, the distance is 60 kilometers. That's going to go here. And the 60 kilometers north is the displacement. 60 kilometers north is the displacement. That's going to go here. So easy enough. Now I just have to substitute in correctly. Speed is equal to distance, which is 60 kilometers, divided by time, which was the 2 hours. Okay, so here I'm going to do the velocity equals the displacement. According to this arrow, I follow it here. The displacement is 60 kilometers north. The time is, once again, 2 hours. Just pull out your calculator and then do the math here. 60 kilometers divided by 2 hours is going to equal 30 kilometers over, what's our only unit here on the bottom? It's hours, 60 kilometers per hour. And the velocity, 60 divided by 2, once again, is going to be 30. The kilometers is here, divided by hours. But notice there's going to be a direction, and it's going to be north. So in this situation, the speed is equal to 30 kilometers per hour. And if we also said same situation, what is the velocity? The velocity is 30 kilometers north per hour, or they say 30 kilometers per hour north, in the north direction. Okay, now let's go for a situation that is slightly different. That's going to now diverge. The two answers are going to diverge. If we remember back from our little thing here, we said it's the same number for speed and velocity until there's some kind of a directional change, and then it starts to become different. And that's what's going to happen here. It says Christian starts at his house and he travels in his car. He goes 90 kilometers north to his friend's house. Important bit of information there. To drop off something, then he turns around, and comes back and stops at his mom's house. This takes 2 hours. Oh, I think there's one bit of information that I forgot here. I should have said he stops at his mom's house, and his mom's house is, oh, whoops, bad me, I forgot. 60 kilometers north of his house. What a mistake. Okay, so in this situation, what I was going for was I was trying to say, like, let's go back to the story from the first problem. Christian's at his house. He ends up, at the end of the story, he's still at his mom's house. And that mom was still 60 kilometers away north. But what I wanted was I wanted him to stop off first before he went there. I wanted him to stop at his friend's house. I just forgot to add that into the problem. Okay, I wanted to him to stop at his friend's house first. Oh, can't write friends here, all right? So I wanted him to do this, to go all the way out 90 kilometers to go to his friend's house, and then I wanted him to go back to his mom's house, just like the story said at the beginning. And I wanted all that to take the same 2 hours, all right? It's like saying, oh, there's this piece of information, it's 2 hours. He actually stopped at his friend's house before coming back, all right? North-south direction once again, okay. Okay, so what do we know? Well, we know he went 90 kilometers north. Now, if he comes back and he's at his mom's house, 30 kilometers, okay, it was 30 kilometers south of where his friend was at, right here, okay? It's 30 kilometers south of where his friend's at. He's now 60 kilometers north at the end of the story, just like in the first problem. So we have to remember that, is that he actually went 30 kilometers, but that was in the south direction. Okay, another bit of information that we know is we know that the time is still 2 hours, just like last time. What is it asking for? Well, it's asking for the speed, and it's asking for the velocity, just like previous. What formulas to use? Well, it's the same formulas from last time. If speed is equal to distance divided by time, we have velocity is equal to displacement divided by time. Now, it's very clear. We got time here. That's going to go here. That's going to go here. But we don't know exactly what the distance is yet. We're still looking at it and we're like, wait a second. So what is the distance? What is the displacement? Well, if you got to start off first by asking yourself, what is the distance? Remember, the distance, there's no regards to direction. So turning around doesn't matter. Your number for distance still goes up. So if the person, Christian, went from here, starting from his house and ended up at his friend's house first, well, how far did he go? He went 90. And then he turned around and came to his mom's house. How much more did he go? He went 30, and then that's the end of the story. So for distance, we don't even care about this north-south. We just look at the number. Turning around and going the opposite direction doesn't make distance go down. So we got 90, we got 30. What does that equal to? That equals to 120 kilometers. Okay, now let's look at it as displacement though. Oops, that's a terrible arrow. Okay, displacement. So Christian started at his house, went 60 kilometers, oh sorry, he went 90 kilometers north. He comes back 30 kilometers south, okay? So what we have to do is we have to look at this, and we have to look at the north and south as like opposites of each other. The 30 kilometers south cancels out some of the 90 kilometers north. In fact, it cancels out exactly 30 kilometers north because it's like you went 30 kilometers one direction, then came back 30 kilometers the other direction. So if we do this, here, let me write it out here. This is like we almost think of the 90 kilometers north. Maybe you think about that as a positive. Maybe you think of the 30 kilometers and you think of that as a negative because it's the opposite direction. So a positive 90 and a negative 30. Let's add them together. We're going to end up with a 60 because one's negative. And that's going to be a positive 60. So then the answer for what is his displacement? Well, he's 60 kilometers. And we said in this example, plus was north. He's 60 kilometers north of where he started. So that's going to be the displacement, 60 kilometers north. If any of this is confusing, it's okay. Pause and go rewind it and watch this part again. How did I end up with 120 kilometers for the distance and 60 kilometers north for the displacement? Okay, now it's just a matter of substituting in. Oh, I'm sorry, whoops, not D, not, that was an S, it's supposed to be for speed, sorry. Okay, so speed is equal to distance, 120 kilometers, divided by time, which we said is 2 hours. And then we're going to say velocity is equal to displacement, which is 60 kilometers north, and divided by time, which is 2 hours. And now we just do our math. Well, 120 kilometers divided by 2 hours, pull out your calculator, 120 divided by 2, you're going to end up with 60. Oh, running out of room here. And we still have our units left over. 60 kilometers per hour. 60 kilometers per hour. That's a much different speed compared to last time. We got 30 kilometers per hour for that speed because we didn't even think about the fact that he, in this extended story, actually went to his friend's house and came back. In that situation, if he managed to get to the same place, his mom's house, but he took a longer route to get there, it makes sense that his speed is much greater. He had the same amount of time to actually go more distance. Okay, now we do the next one. 60 divided by, velocity is 60 kilometers north, divided by 2 hours. 60 divided by 2 is 30. And our units is everything left over here. Kilometers per hour in the northward directions. So again, notice, as soon as the story involves turning around, changing directions, these two answers will diverge now. They will be different answers, okay? Most of the time when people talk about speed and velocity, they're mostly just meaning speed, okay? Because they're just talking about like their car and how fast it's going. They're not thinking about, oh, I turned around, I came back, well, my speed is still this, but now my velocity is different because where I started at, I just went back and canceled some out. They're not thinking about that, all right? Okay, next thing. Not only do you have to be able to use the formula for speed and velocity, you also are going to have to be able to use the speed and velocity formula to calculate something else, okay? There are going to be situations where you know the speed of something and you're trying to use that rate to find another quantity. Let's look at this problem. It says the car's maximum speed is 150 miles per hour. So you already know the speed. It's given to you. The speed is equal to 150 miles per hour. If the car kept the maximum speed for 0.5 hours, likely impossible. It's really difficult for a car to keep for a whole 0.5 hours, a whole half hour, keeping its maximum speed. Okay, unlikely, but I wanted to use easy numbers for this problem. How far would it travel? Okay, so we know in this scenario, the car, because it's saying if this happens, so we imagine this happened in this scenario. 0.5 hours, what is that? What information is 0.5 hours? Hopefully you can see that it has hours in it. That is a time, 0.5 hours. How far would it travel? Notice for this problem, it doesn't tell you about anything about directions. So what I'm going to do is just assume this problem is only asking about speed. Well, I wrote it, so that was my intention. We're only talking about speed, all right? But what is it actually asking for? How far would it travel? How far? What is it asking for if it says how far? Hopefully you can see how far means distance. We talked about it before, how far could mean distance, could mean displacement, but in this situation, because we're dealing with speed, the only thing that it makes sense to be finding here is distance and not displacement. Displacement would be a vector quantity. Speed and distance are scalar quantities. Okay, what's the formula to use? Well, we know that there's the speed formula. Speed is equal to distance divided by time. I'm going to write it bigger right here. What am I doing? Speed, what am I doing? Speed is equal to distance divided by time, okay? Now, in previous situations, we did not know speed, we did know distance, and we did know time. It was very easy. We just calculated it like that. But this is a different situation. We now know the speed. We now know the time. What we don't know is the distance. Now what's going to happen is if you can still use this formula to find the answer, but in this formula, the distance, the answer, the variable that we are trying to solve is going to be right here on the right-hand side, and there's going to be a number that we do know. That number is going to be 0.5. It's going to be on the right side with the thing we're trying to find. There's going to be a little bit of algebra necessary to solve this. There's going to be like one extra step. Now, I can teach you a trick that can avoid that extra step. It's not a very profound trick, but it is helpful. Draw out a little triangle here, like this, okay? Make the triangle have 3 parts, One part on the top is by itself and two parts side by side below it. Take these letters for the speed formula, put them in the box. The distance, make it be on top. The time, make it be on bottom. And the speed, make it be down here. Just memorize that little formula right there with this triangle. Distance on top, speed on bottom, time on bottom. Okay, now if you use this formula, it's very simple. It will help you figure out what the formula will be for what you're trying to find. And it goes like this. Cover up what you want to find. Cover up what you want to find. What's left is the formula. What's left is the formula for it. Okay, so all these previous times, what we had done is we'd said, okay, we want to find speed. Cover up speed, okay? We've wanted to find speed. Well, what's left? Look right here. This is the formula. Distance divided by time. But this time we're not finding speed. What is it that we're trying to find? According to our what we're trying to find, it says we're asking for distance. So cover up the distance. Put D equals down here. What do you see is the formula. What's left is the formula. S and T, but the S and T, they're not on top of each other, they're next to each other. So what we're gonna look at this like is multiplication. Speed multiplied by time gives you distance, and that it just does, okay? Speed multiplied time times time. The speed, how fast something's going, multiplied by how much time it's going. Let me say it again. The speed of something multiplied by how long it's traveling, the time. If you multiply them together, you'll figure out the distance, how far it went, okay? And this is a little trick, it just works. So this is the formula we're going to use. Distance is equal to speed times time. All right, and in fact, I'd say just memorize this thing right here. Just memorize this pyramid. Speed, distance over time, okay? That's not cheating, you can just write that down on your paper whenever there's a test. Just write it down. Cover up the one you don't need. What's left is what the formula is. Okay, so now here is our formula. Distance is equal to speed times time. Already said the speed is here, 150 miles per hour. I'm gonna put parentheses around it, it's nice and clean. What's the time? How much time is it gonna move that speed? And the answer is 0.5 hours. Now we just grab our calculator, we multiply 150 multiplied by 0.5, and you're gonna get it's 75. Now what are the units gonna be? Okay, well, here's where you can see why this formula totally works. Because, okay, you got miles per hour, and it's multiplied by something that has hours. This hours is gonna end up on the top. Let's see if we can make that cleaner looking. This hours is going to end up on top, and now you're going to have hours on top of the fraction, hours on bottom of the fraction. Anything divided by itself can be canceled out to 1. Canceled out. And now you're like, well, why don't you write the 1? Because any number multiplied by 1 is just that number, so we don't really have to write it. So what's the only unit that's left? It's the meters. 75. Oh, I'm sorry, not meters, miles. Whoops, we were dealing with miles. Okay. Distance is 75 miles. So there's your answer. If a car kept the maximum speed of 150 miles per hour for 0.5 hours, how far would it travel? It travels 75 miles. This is using the speed formula to find something other than speed, okay, based on what the problem's telling you. One more and we're done. Car's maximum speed is 150 miles per hour. That's the same thing we knew previously. Speed is 150 miles per hour. If the car kept this maximum speed, how long, oh, here's the important part. how long would it take? How long would it take to get to a town 400 miles away? So what is the other piece of information we know? This is a formula that has 3 parts. If we know 2 parts, we can solve for the third one. What is that other piece of information? Hopefully you can see it's the 400 miles away. So what is that in the formula? Is that speed? Is that time? Or is that distance? Well, we already know the speed is 150 miles. Hopefully you can look at that and say, well, 400 miles away is not a time. There's only one thing left. That's a distance. 400 miles. What's it asking for? Look at the problem. If the car kept this maximum speed, how long would it take? That's the question. How long would it take? So therefore, what is it looking for? How long would it take? We are talking about time. So what's the formula to use? Write it out here. Speed is equal to distance divided by time. Cover up the thing you don't, cover up the thing you want to know. It's asking for time. Right here. What's it asking for? It's asking for time. So cover up the thing you want to know. What's left? What I see is distance on top divided by speed. That's the formula that's going to find you your answer. So now we just write it out here. Time is equal to distance divided by speed. What do we know? We know the speed. That's going to go right here. We know the distance. That's going to go right here. Let's write it out. Time is equal to distance of 400 miles divided by the speed of 150 miles per hour. Okay. And this one I'm going to have to use a calculator for. All right, 400. I wish I could have a calculator pop up right here so that you can see it as I'm doing it. But I don't know that that is a feature. 400 divided by 150 gives us 2.67. I'll round that to 7. Now, what's going to happen here with these units? What do you think is going to be the unit for the time? 2.67 what? Hopefully you take a guess at what it is, and you can see it's going to be hours, but I want to make it clear. Here's the units right there. Let's write them all out, the units. Miles over hour. Well, that's an interesting one to look at, okay? How can I explain this one? All right. Well, the way I like to look at it is like this. You're dividing by a fraction. This is a fraction down here. This is a fraction. And I learned in Texas, we always said when you divide by fractions, it's easy as pi. And the saying said you flip the second number and you multiply. Dividing by fractions, easy as pi. Flip the second number and multiply. Here's the second number is miles per hour. I know you're like, well, those aren't numbers, those are units. It still works the same. Okay, you flip the second number, which is miles per hour, you flip it upside down to hours per mile. And you multiply. What were you multiplying it by? You were multiplying it by this miles here. And so now you have this, miles multiplied by hours over miles. Miles on top, miles on bottom, they cancel to just the number 1 multiplied by hours. We don't need to write that because 1 times hours is just hours. It's not 1 hour, it's 1 times hours. And therefore the only unit left, hours. So 2.67 hours. If a car is going 150 miles per hour, how long is it going to take to get 400 miles away to a town 400 miles away? It's going to take 2.67 hours. Okay. Okay. I hope that that was easy enough. Next time I see you in class, we're going to be using these formulas to solve problems in class. We're going to get all this practice in class. Okay. Thanks for watching, and